Hey people, Aman Vyasya here. This is a different kind of video. It's in this video we shall be doing some maths. Okay, so I think you have seen that video in which I talk about palindromes. Okay, just a refresher. A palindrome is a number which is read the same forwards and backwards. 656 is a palindrome number because if you read it backwards or in reverse order, which is 656, it stays the same. Okay, let's say 1221, it's also a palindrome number. 12321, that's also a palindrome number because if you read it in reverse, 12321, it sounds the same. Okay, so I was trying to find palindrome numbers, and in math there is kind of a theorem that if you take any number which is not a palindrome, let's say a 45, and if you add it with the reverse of itself, so if you add 45 plus 54, then well you get 99, and 99 is a palindrome number. Let's try something else. Let's try 29. Well, if you 29 is not a palindrome, but if you try to find its palindrome, what you can do is 29 plus 92. So this would be the first step, and you would get let's just see what do you get. Oops, I think I have some kind of an error. Never mind. Okay, so let's just go through Python and let's just say this, you get 121. So in one step you reach to your palindrome number. Let's say you have 27, 28. Let's try 28. Okay, so you have 28 and it's not a palindrome number. So to convert it into palindrome, you take the original number plus you just basically add the reverse of that number, and you get 110. Well, 110, it's not a palindrome number. So what do? Well, you take that number and you just add the reverse of it, and yeah, well technically it's 0 1 1, but Python doesn't like it, so we'll just put 11, and it's 121. 121, it's an palindrome number. Let's try to do that. Shall we? Yeah, I think it should work. We'll just put an exit and we'll just run the mark2 file, enter the number. Let's try converting 96. Yeah, so 96 converts, well basically 96 converts to a number. It goes to 4884 after 4 steps. So it's 96 plus 69 and then some value and then so on and so forth. Eventually every single number is supposed to reach another palindromic number. We can try 89. It's a famous number. We'll try 89, and 89 will take 24 steps, but eventually it shall reach a number which is palindromic. So this is a palindromic number. Now I was doing this yesterday and I thought, why not just check that for the entire number, like from 1 to 100. So let's see that. Oh sure, we haven't saved that. Okay, and yeah, okay, so 1 goes to 1 after 0 steps because 1 is already palindromic. 10 goes to 11 after 1 step. Makes sense. 11 is already palindromic, so we don't do anything. It just takes 0 steps. 16 goes to 77 in 1 step. 28 goes to 121 in 2 steps. That's fine. 39 goes to 363 after 2 steps, which makes sense. Ignore this Lychrel candidate stuff. We'll get to that. 49 goes to 484 after 2 steps, and it's just basically that stuff. The highest we see is at where's 89? Yeah, 89. It takes 24 steps, and I thought, okay, interesting. It takes a lot more steps. This is the list from 1 to 100. How about we just try to go till 150? Let's just play it safe. Let's see what happens till 150. Sorry. So yeah, our list is entirely fine till 150, and yeah, it seems to work, I guess. Now let's try 200. Let's see what happens. Okay, and we'll just run that. and it did go till 200, but I think there's an issue. See, 194 works, it goes 195, it works, but there's no 196. What's the deal with that? So I'll change some code. I'll show where's so I added this code in. I'll just comment that out. Let's see if it works again. Yeah, so when I try to run this program again, it works fine, and it goes to 1 from 1 to 195. It does, but then for some reason it stops at 196, and I thought that there's something wrong with the program. So I went ahead and checked 196 for myself to see that what is wrong with 196. Like, why wouldn't that work? So we'll just yeah, okay, so we are back to normal. So let's just run Mark 2, and let's just see what happens with 196. Okay, and 196 just keeps on running. I mean, it doesn't stop. You can't find a palindrome with 196. There seems to be some kind of an error, which doesn't make sense, which sounds very weird, right? I mean, why is that the case? Let's run Mark 1 again, but with the new code. Let's try go to 1000, and we just run it, and it goes till 1000, but you might see that 196 is missing, and 691 should be also missing. Let's see, 691. Yeah, 691 is missing for some reason. Weird, right? Let's just try that again. We'll stop printing this, and we'll try to find this. Okay, let's still go to 1000, and these are called Lychrel numbers, and forgive me if the pronunciation is wrong, but these numbers you cannot find the palindrome of. Like, if you start with 196 and then add 691 and then keep on doing that, it will literally go till a million steps, a billion, a trillion, a quadrillion, but still it won't, like, it can't find a palindrome. And this is something that I just found, like, I rediscovered by accident. And well, you could go till 10,000, why not? And these are the Lychrel numbers which do not have a palindrome, as we don't know that. Okay, it's not proved that they don't have a palindrome. I mean, we can check till trillions and trillions, but we can't go till infinity because that we don't have that much computing power. And there are 246 Lychrel numbers from 1 to 10,000. So that's it. I mean, you can think about it. If you can experiment with it. I'll leave this code in the description if you want. You can play around with this code, have fun, and yeah, that's it for this video.